Welcome to another video on my Raspberry Pi 1, which is connected to this breadboard with electronics and some fischertechnik electronics as well, with a switch, two LEDs from fischertechnik and an MCP 23008 I2C chip with resistors and normal LEDs for binary counter. Also two probes connected to the I2C wiring and two probes connected to the first LEDs, and via band cable connected to that Raspberry Pi 1 running Raspberry and Linux with a RaspberryPi Plus on top, connected to serial cable, Raspberry Pi camera and network cable for VNC. And for this binary counter it is connected, programmed in C. For another program which shows some other things with LEDs, it's also connected in, also programmed in C, and I can show that as well, of course. First of all, let's see if the wiring, which I had to correct for some reason, does work, and I'll show you later how the algorithm is for now situated. And as I expected, kind of, nothing happens, which is because probably, most likely, there's a wire out, so I have to fix this wire momentarily. And then it is very nice if I don't block my own light. This wire, which is for the I2C, has to go in here. So let's see if it works now. The answer is no. So I am going to boot the whole of the system. Power off, power on, and it still doesn't do anything, which is not a good thing to start with. I had to fix the green wire and the gray wire, and unfortunately still nothing is happening. Which seems to happen once in a while. I should have checked earlier, but such is life. Does this work anyway? Even this is not working. So I will have to check on, let's see, hold it a little bit longer. No, so nothing is working at all, which is not a good thing. Alright, let me check the wiring, because if even this doesn't work, then there's something definitely not right. Alright, and then everything works. Why? Because the wire from this switch here, one of the wires was out of the connector, so that was the cause. And well, I restarted the program, and one of the clock signal, no, the data signal of the I2C was out. So once again, so now it does work again, as you can see here, and as you should be able to see here. Let me check this one. Yes, it is delayed. Oh, yeah, right. And I would replace the red LEDs here. That is another thing, because now you can barely see anything happen. Here you can see the things happen. So let me change them for one of these. And then I have to verify which side is which. So let me, on the spot, replace this red LED. And I better use this one. So carefully take it out and then gently put it in. And if everything goes right and according to plan, this one should start burning. Yep, it does. The second red LED is out of counter right now. Let's check for this one. Do I see anything? Well, barely. Yeah, I see here a glimmer. Alright, here, here and here. So anyway, that shows that this is working nicely. Good. Next thing, like I said last time, I have to change the algorithm. Why do I have to do that? Well, simply put, the objective is to have the count act on the switch. So this for loop, no, this for loop has to be in here. And now I have to be very careful. And this for loop has to be in here. So how am I exactly going to do that? First put them out of it. That's a start. Yeah, because this is the counter. This is the counter itself. The writing part, not the counting part, this is the writing part. So this goes here. This goes out. And that's how it should be. So let's give it a try. Alright, so now it doesn't look so nice, but I only have moved certain parts. So right here is the if. The closing bracket of the if is now here, which means that I still have to indent for clarity everything that is here in the for loop. Same thing with else if, which was after this one. The else if is now here and the closing bracket is now here somewhere. This will compile nicely, correctly, but it looks like not very nicely. So what I am about to do is say, okay, this one goes here, same here, and then this all have to be indented. Not like this. And sometimes you forget to press escape to make another thing, and now, oh wait, I forget one thing, this one. So now this for loop has been edited correctly. This one still has to be indented. This one as well. And this one as well. And now the structure is nice and clear. Although this one should be indented as well, of course. So now this is a very clear structure. If the switch is pressed, if the button is pressed, switch or button, whatever, read 1, then do the counting. Nothing has changed here. Then wait for a quarter of a second. Then else if not pressed, do the rest. So, and here things should be indented as well. But it is, yeah, for visual stuff better, but not strictly necessary. So let's compile first. Should be no problem. And in this left window, the compiler is waiting for enter. Ah, yeah, right. Of course, I have to be in the correct directory. And go. Function main else without the previous if. Well, I don't agree with that one, because this is an if. Oh, probably because of this. But this is an if, and this is an if. Would it then help that I say the delay starts here? I can try that. So I say, okay, right here. And this goes better. So, lesson learned. With with one if statement and an else if, there should be nothing in between. Good to know. Okay, let's roll. and execute, see whatever happens. And you can see the counter going on. You can see it here as well. What happens now if I press this particular switch? It counts down. No, it stalls. It stalls at 5. And it goes on. At least the program goes on. How long should I press it anyway? What's going on? It's not doing anything anymore. Oh. Right, that is not the intention. Well, it may not be the intention, but is it indeed what the program does now? Start again. Oh, that's not good. This is definitely not good. You can see what is happening. It is indicating 5, but that's impossible. Although here is now an extra delay, which I don't care about because that's only in the if. As long if inside the if was not pressed, then it should go to this, no problem. And set bit down. But the LEDs are still on position, as you can see, 5, which is not the intention. Oops, what is happening? To clarify things, or an attempt to that, I have here tidied up the algorithm. Everything is now indented as should, and that also means that, let's see, it's going down to 8 here, and here it's from 7 to 0, but I have calculated that before, because 0 to 8 is with last digit 7, so here I have to count down from 7 to greater or equal than 0. So that is all right. And this is the same. The only thing I doubt is this delay, but let's keep it this way. What I still don't get is why it keeps hanging, which it is right now still, on these two LEDs. That does not make sense. Let me see if that changes when I restart the algorithm, although let me save this first. Compiling should be no different, because I only indented, I didn't change anything. Yeah, right. So let's start. Okay, this is very strange. It doesn't count. So this is very, very odd. Oh, by the way, now I see something else. The data line is off. The clock is on, but the data is off. Wait a minute. That is something that I forgot to watch. And I didn't change the signal line. But who knows? Yeah. Okay. And that meant everything. So, although I didn't change anything from the wiring, apparently the data line was so far out of the connector that it didn't work. Alright, so now we are looking at these LEDs, which are nicely working again. And now what will happen when I press the switch, because that is what it is about. And then I have to keep, okay. Oh wait, that's another thing. If I press the switch, so normally when I don't press the switch it does this one. When I press the switch it starts over with this. But what happens when I release the switch? Will it keep doing this? Or will it immediately go here? So I need to introduce a status. That is a very nice one. Will I have to keep pressing the switch or not? Okay. Very interesting thought. Yeah. Where is my cursor? My cursor is right here. So, and a status is being introduced, let's say right here somewhere. Yeah. Status, let's say 1 or 0, usual. Switch status or count status, whichever. Switch, that's okay. Switch status. And I have to initialize the status. So it is best not to do it like this. So I delete it here and I, oops. That doesn't go well. Here I am. Switch status is 0. Okay. Having done that, I can go here and I say here switch status, and I think I better should do it here. Button pressed, and okay, right here switch status becomes 1, and I have to print it, of course. Switch status %d or %d, with this. Then I should know what is what and how. And let me do that exactly here. And switch is 0. Should be right, I think. Time to compile. Yep, alright, let's see whatever happens. So let's see whatever happens now. And I am pressing the switch. And releasing. It goes by too fast. So this is not the correct place. Do I see it somewhere? I can't even see it. This is 4, this is no, this I can't even see where I am. Oh, that is no good. Y is 7 again. Button not pressed. Okay, this is definitely the wrong position. But I have to wrap up. Time is up. So this is something that I have to check for next time. So for now, well, change the algorithm. Let me run it again. So this is wiring Pi with binary counter, and I told you I would show you the other one as well, so let me do that. This is demo. Without button pressed, and with button pressed it looks like, well, nothing, not what I expected, but anyway, this is what this one is. Back to wiring Pi, and well, some wiring problems, unexpected, changing the algorithm, and that should work, but somehow the status has to be put in another location. For now, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me via Twitter. If so, please retweet, like it, leave a comment. You can also follow me via Instagram. Please like it, leave a comment. You can show your support by making a small donation via Wired or PayPal. And you can also become a patron and have your name mentioned as such in support of my videos and blog. More information under this video. Name of the website, Instagram and Twitter names, and the ways to support me. This is to be continued. Thanks for watching.